Welcome everyone. We should be live to another low-level Linux live stream here on our channel. For those who are new to our stuff, we do this here regularly since some 3 years and run a Linux distribution, kinda like Linux from scratch, but not that. 20 years in the development, previously known as Rock Linux. And what it does is fully auto. You also don't see this because we are professionals. So yeah, we developed this here since 20 years, and people are always asking, can you explain us this stuff in more detail? Of course we can. So let's build the release. So should be also, by the way, we should quickly update the release. Good that we don't forget that. So that's supposed to be the 21.12 release this week. So we should reconfigure. So if you download T2 from our website with Subversion checkout or release tables, you would get the sources and then run here the configuration like that and dial in here what you want to build and optimize for. We have done this already. And then we start the build. And it is basically as simple as that. And in our case, fully automated. And again, I only use the term Linux from scratch loosely because it built Linux from scratch. So to explain what it does is we have multiple stages. Stage 0 is a toolchain stage, then cross and eventually native. If you want native builds, we can build half of the package, the cross compiler though. So it starts with a 00 dir tree. This is just the Linux, the file system hierarchy standard. Then next, this is basically just some directories. Next, glibc or any other C library. We also support musl and uselibc. Initially, we only need the headers, so 0, toolchain, glibc just extracts the headers because we need a cross-compiler and stuff. And the cross-compiler, whether you support and target and build for x86 or PowerPC, those headers are a bit different, especially all those platform-specific system call and other bits. So first the headers. Again, this is not the C library because first we also need a compiler. It differs a little bit. Many people on other distributions say do not build stuff as cleanly from scratch as we currently do here. Many distributions simply start with their last year's release or something. So making stuff easier, but also mixing last year's libgcc and stuff potentially in there. Then you see here some random stuff like CPIO flex. Half of the stuff is not necessary, but some stuff like, for example, GMP, we need this R support libraries for the C compiler. So for example, GMP, we would need MPFR, ISL for the cross compiler, and bin utils, for example, so that are already the bin utils, binary utils of GCC. So basically the companion package to GCC, to the GNU compiler collection. Bin binary, aka it sounds a little bit like binary image and stuff, but no, those are binary executables as opposed to source. So bin utils that build already the cross assembler, linker, object tools, and so on. GMP, so CMake. Again, so CMake we would normally not necessarily need, but the toolchain stage is building not everything, but like 90% plus what we would need. That is not necessarily on the host system. So if you build on some random Debian or Gentoo or so install, then you might have some of those things missing. So we just built them here so that they are there in case of, and in some cases, especially like CMake has actually some fixes for cross-compilation. So in some cases, if you would use the host CMake, that would actually not work with all cross-compilation details. So yeah, this is why we built CMake, for example. And so MPC, ISL, as mentioned a minute ago, PPL, these are mandatory and optional. For example, ISL is optional. Other stuff is not. Actually, I should check if PPL is still a thing. But these are support libraries used by GCC, by the GNU compiler collection. So we need to build them too. Again, it could accidentally randomly work with stuff from the host system, like you install a Debian, but people, even though we take 90% plus measures to install all the really important stuff, people still open bugs or write us an email and stuff. It's like, yeah, I tried to build this on Fedora and on this random Linux distribution 1852 or something, and it doesn't work. And so, yeah, although we prepare all kinds of details, are still room for errors. So best recommendation, always use T2 to build T2, although theoretically once upon a time and usually randomly it does work, but near 90% plus if you're feeling lucky. Otherwise, best just download a T2 release and build this in a VM. So GCC, so that is now again, so here is the stage also, by the way. Does it probably, or this doesn't show the mouse pointer in that, does it? Selection it shows. So here's a stage, and we might modernize the build output further. But right now, for the last 20 years or so, build output looks like this. And here's a stage and building the package, the Devil GCC version. And so this is a cross-compiler, the more main component that we will use to build all the packages, so it's later system packages. And this is actually not only a quite huge package, as you might imagine, and nowadays also it comes C compiler, C++ compiler, theoretically Objective-C. Once upon a time there was Java, now there's also Go, and also a handful of support libraries like libgcc. Basically it's a GCC companion library having all kinds of software implementations, like software library, like low-level library functions that your processor might need, your processor architecture. For example, RISC-V doesn't have rotate, as crazy as it is in the base either anyway. So there would be for RISC-V rotate instructions, but even for x86 there are arithmetic shift or shift with carry or 64-bit shift that needs to be implemented with 2 shifts and a carry and stuff. So all this kind of, or other exception unwinding and other such kind support stuff, including, I think, if you build with stack smashing protect and other such advanced optional features, they also in part or mostly live in libgcc. So then it continues just with some other support stuff. The order doesn't matter too much. Some stuff we could have built before, but that is just like libxml. You might wonder why we do build some stuff, also M4 macro preprocessor. Again, it comes with Linux distributions. M4 is this kind of stuff. 20 years ago, it was more often broken, there was more development, so some of the stuff is simply historic. Nowadays, we probably do not really need to build M4, but it has been there for 20 years, and it's like, yeah, it's mostly a no-brainer. The Ryzen 5950X. Also, yeah, for your reference, right now we're using my overkill build, previous video on my main channel, 96 gigabyte, liquid cooled, with their Bauer offset plates, plenty of videos on the moment channel. Asus X570 Ace workstation board, and yeah, their Bauer offset plates for a little bit better. Like, how much was it? Was it 3 to 4K or Celsius, which is obviously equal. Better temperatures for a little bit better turbo boosting, which is, yeah, grab, what do we, megahertz, CPU info of sort, I think. Okay, single boostings, like, yeah, thank you very much. It's configure runs. Otherwise, yeah, we probably all, usually this was supposed to all core boost like 4.6 gigahertz. Anyway, just to have a reference why this builds so epic, thread-rippingly fast, this is why. And unfortunately, not everything is embarrassingly parallel. Lots of this configure runs and other LTO linking stuff. We also, by the way, built with LTO, as you at times see there, as it's disabled for some packages. So this is relatively optimized, smarter optimized using our profile database that is built into T2 for selectively building everything for source except hot code passes with O3 for best cache memory footprint and yet optimized hot passes, a feature unique to T2. Otherwise, sure, you could use other profile guided optimizations, but the beauty of that is in T2 it is platform independent, and we can profile on x86 and use the same stuff on Spark, and also don't have a test suite and don't need to profile guide train on a test tube, but can have this simple stuff. So sure, if you throw way more CPU cycles on compiler native profile guided optimizations, you can get better binaries, but that is a pretty nice high performance and not too much build time wasting intermediate step. So LLVM, the new, also yeah, autoconf, so libxml I wanted to say, so some of the stuff, as I said, 20 years ago, 18, 15 years ago, there were more like libxml 1 and 2, and this is obviously now since 15 years or so libxml 2. We again only built here some bootstrapping stuff to be sure what we have there and to make sure this stuff actually really works. Autoconf similarly can be available, but even that notoriously like 15 years ago, and also yeah, doing this stuff for 20 plus years, right? So I remember all the GCC 2, 95, 2 and 3, and eGCC and glibc 1 to 2 and so on. And like, yeah, autoconf and similar stuff, 15 years, randomly broken every, especially Fedora. Red Hat had a like GCC, eGCC, infamously versions of mostly broken and stuff. So LVM, the new low-level virtual machine infrastructure that nowadays serves as a wide base for a multitude of compilers, not only Clang, but also I think Zig, although they rewrite this, but otherwise Rust, and of course Mesa 3D GPU stuff. Other GCC support stuff, so MPFR, let's get here also supporting, maybe we detach that as we live stream that today like that, to have here a better reference at hand for me. Let's hope I also, this is still in focus, amazing, MPFR, so this stuff is MPFR multiple precision floating point computations with exact rounding. By the way, I just, does that have has a typo. So the usual win-win of course we have some stuff to do. We will continue with real-time reporting about the details of each package. By the way, if you're wondering how long this will go, I think this should probably be mostly be built in 2 hours. And that includes not like doing this manually in multiple days. Some people don't believe in our automation. And so yeah, fully automated, epic thread ripping through this stuff, most likely in 2 hours, plus minus, maybe 2.5, depending. I think this should build error-free with our years here live on YouTube, live streaming all of our work, like just all the other yesterdays here. And MPFR, so here was MPFR, let's fix the typo here on the fly. Check that in a second. So we already thread ripped through LLVM, built that in, so fast it scrolled away. It also built bin86. I recently, so this bin86 are like NASM or Turbo Assembler compatible assembler. I recently wanted to disable that, so complete, another complete, like not GNU binutils 86 assembler and loader. Do they make linker? This is historically was used for Lilo. I think I recently wanted to remove that, but maybe even the Linux kernel still uses it for some boot code. I need to check actually. NASM is another portable assembler, a little bit superfluous if you ask me. So that is another x86, which can create a wide range of object formats. So some of the stuff like NASM, we might mostly need that for Firefox. Again, I tried, so this is a more minimal desktop selection of most minimal Xorg, TWM, probably Blackbox, and Firefox, of all things, because obviously what is the operating system nowadays without a web browser? I tried to disable a lot of stuff, and I'm pretty sure bin86 was used in something, maybe not grub, maybe more Linux kernel, and also NASM. I'm pretty sure Firefox wants that. Maybe you can disable that, but then you lose some features. I find it a little bit crazy that we need additional assemblers next to bin utils, GCC and LLVM clang, but apparently still some single instruction multiple data optimizations are at times still written in a way. So this good old-fashioned assembler formats. NSM, what does N, is it N like new, or what did the stand for? Net-wide assembler, portable, modular and stuff. And there's also a new version, I think YASM might be compatible. Yeah, YASM is a complete rewrite of NASM, a new BSD license and stuff. I actually slightly wonder if we should put into, do we need, so it was bin 86 NASM or better than YASM or so. Stuff to research another day, and welcome everyone. People comment some other, what even is that? If something else is better, feel free to send a patch telling window manager this, which reference to that in terms of better. But yeah, so text info or tech info, always leave in the comments below how you natively pronounce that. I read this for 20 years, but it's like, yeah, do you pronounce it like tech? Also, even tech or text, people also fight each other, similar to GIF and GIF and stuff. Text info, we need to build lots of documentation of packages. Clang, of course, the new C language front end. Also, yeah, some people pronounce it Clang, other C lang. Also, I mean, I previously preferred C lang for C language front end until too many LLVM developers told me, yeah, we want this pronounced Clang. Personally, not the greatest fan of that, but anyway. So that is similar to GCC, a C, C++, Objective-C++ family of languages front end using the LLVM low-level virtual machine, bytecode, intermediate representation, APIs and interfaces. Usually we wouldn't need Clang, and until recently we didn't have Clang in the minimal Xorg selection. We only had to add this for Firefox of all packages. Their new C binding generation with Rust is apparently relying on Clang. Beside, theoretically, the Firefox people want Firefox build or only officially support Clang, although we just built it with GCC and it usually just works the same. You could argue, yeah, but build it with Clang. The problem is we don't necessarily have Clang for all architectures, so we would, for some outliner architectures where LLVM Clang is not stable and supported, like Itanium or other such stuff, maybe Super H or other similar alternative and vintage architectures. So we would need to support it anyway, and then I find it more clean if my primary choice right now, again, you can choose Clang in T2 and with previous videos and Whole Ice was with that, but if you choose GCC as your system compiler for various reasons, whatever they might be, better optimization or other broader compatibility or more testing, then you should get everything built with GCC and not some stuff like Firefox randomly with Clang. In my opinion, that's not a good style. Not the greatest. In my opinion, code should be written standard conformant. So if you write C, C++, Rust code, it should be standard conformant Rust code, not accidentally only work with Clang because YOLO. So anyway, so far it works, but we still need it. Leave in the comments below. You can always leave comments. This would always be project like, hey, we could try to patch that. Maybe, but maybe not, depending on what they interface there and how they use it. To Firefox build with C bind gen without Clang, but yeah. So get text, the programming internationalization library and tools file. So again, we need this because this is Toolchain, right? This is building native tools, this is building a native file. Also, again, because some builds sometimes needs the very latest version. If you would otherwise build on last year's T2 or yesterday's Debian, you might get random build errors in this way. We're building the latest and greatest file just so that it's there for programs that might use it in the build system to have the latest version. libffe, foreign function library. Actually, I'm wondering why we built that here in the toolchain. Maybe there's a reason for that. FreeType. So FreeType is a crazy one. We only built that maybe for some bootloader details. Probably grub2 or stuff needs that in theme generation stuff. This is why some of the stuff is crazy. Also find utils. There was even a bug 18 years ago where find with multiple predicates and prune didn't work and was even causing build issues. So this is why one of those stuff, sure, this was only some years Debian and Fedora shipping broken by default find utils, but yeah, there is not really a point to remove it now 15 years later. Also make, similar to that, make you some packages always at 18 years, 15 years more or 10 years more. Nowadays make barely gets much changed anymore, but there were cases where make files and projects needed like this year's make features, and this is why we built it just in case to avoid random stuff. Similar tar, just in case for features and support and stuff. Also, if you build on macOS, theoretically you wouldn't have GNU tar. So if you build on T2 on foreign other OS, you at times would also need some of these tools just for the build to function, similar to Python in case it's not there, because we nowadays, unfortunately, recurring theme here, once there were a dozen sucking build systems like Make and GNU Auto Tools now. Everyone had their own. Now we have 24 sucking build systems, so we also need Python, Meson, Ninja, and like they are speaking about which. And this is why not necessarily in the build system, not necessarily the latest version, not necessarily latest patch for cross-compiling and stuff. And this is why we have to build them here. Similar unzip, you might wonder, why do we build some of the stuff again? Unzip, Firefox or other stuff needs this at times, or some Java packages for Jar files and so on. glib. So the crazy thing is glib, again, one of those packages, until 10 years ago or so, we didn't have glib in there, but nowadays we need package config, and package config has a glib dependency. So this is why, as crazy as it is, right? How long are we into the live stream? Hey, 25 minutes or so probably the build. And we so far only built across, well, we extracted the Linux kernel headers, we extracted the libc headers, we built cross bin utils, cross compiler, and otherwise probably spent half of the time or so compiling random stuff. And also ICU4C we only need because we built all cross so that we can support 25 architectures from ARM to RISC-V over Itanium, Spark, PowerPC, MIPS, and so on for all those fans at home with the P3, SG-Octane, and so on. And this is why we cross-build everything, also including x86, where we could build natively. And this is why we need some of the stuff here that just scrolled away is only for cross-build, like ICU4C. We only need that helper stuff for, I think, this dictionary packing or whatnot. Also gperf and perfect hash. Wayland also, I think, yeah, so Wayland, this is the Wayland protocol generator stuff. So we only need that in cross builds. T2 actually has some special metadata marks for that too. Actually, I should test them more often if they really work, because nowadays 90+% only cross-compile, as crazy as it is, because we support basically everything. And at least the cross-compile case is 90% plus tested. I should only actually sometimes probably do a native build and check that we don't build all the special stuff that we mostly need for cross builds. Markup save similar, so we built that for I think Firefox dependencies, similar to Mako. I think, oh no, wait a second, I take this back. Markup save and Mako, I think, are both for Mesa 3D from the top of my head. So they need that. Also get another build system, right? Scons, similar to Meson, CMake, Ninja, and so on. So grub2, you might be wondering, why did we build grub2? Because cross-build and we need grub image generator natively. It might not be in the system, especially if you build on an M1, previous video, Apple Silicon, or if you build on your Itanium or SG Octane stuff, or simply don't have all the developer tools things installed on /dev package distributions. And this is why we need grub for the MK grub image generation stuff at the end for bootable ISOs. So now we finally entered, so we are 26-ish or so minutes into the build. This was also Toolchain, right? So now we have all the tools fully automatically built. Again, if you are not building Epic Threadripping Ryzen 5950X, then that may take hours or days or weeks. And yeah, here it took 26 seconds. So now we are in the stage 1, in which I actually the last day's reworked. Previously, stage 1 was all our cross-build stage, and there was nothing after that in a whole cross-build, unless you native build. Nowadays, we refactored that the last weeks and months, majorly. So now we have 2 cross stages because we simply had too many interdependencies of full-featured bootstrapping stuff. So what already scrolled away are the Linux headers. So this is just, I think maybe a little bit more full-featured. I think we did this twice. It's probably just paranoia of maybe there are 1 or 2 generated things or corrections missing. Then glibc, so that was the system C library in its 64-bit variant, and also in our case multilib 32-bit variant for if you would run 32-bit Wine or other legacy applications. And the 5950X built that in a whopping 59 seconds or 51 seconds only. We, by the way, improve build times here as we usually do with building this in tempfs, which obviously gives a quite noticeable improvement in build times, maybe 10, if not 20%, depending on your package, so that all the individual packages here are built in there in tempfs, not to even, this is the fastest PCIe 4 SSD, but obviously memory after the fastest new caches and the memory. And yeah, this stuff being 72, I think, was it 72 megabyte? The Ryzen 5950X has so 72 megabyte caches there for your files, otherwise memory. And certainly with build times of 2 hours, every tiny 10 plus percent welcome to speed this up. And of course, you see a parallel build using 32 jobs. We of course use all the threads available to greatly, embarrassingly parallelize the build here. So welcome everyone. In the meantime, we have there some comments also. Non-GNU systems, non-GNU make. I think I probably mentioned that. The same for other Unix tools. Like, yeah, I mentioned this in the case in point of tar, but thanks for pointing that out again. So this is basically how it fully automatically goes there. Again, we can do some improvements. So theoretically, this typo and nothing like finding typos. This is the usual win-win, right? Why do we do this? I need to build this anyway, and I can newcomers to Linux or Unix BSD systems and otherwise low-level tech or full-stack development hopefully learn something with why is all the stuff built, how is all the stuff built. And T2, in my biased opinion, one of the best documentations you could find of metadata of mostly codeless, unless crazy configuration stuff, and then it's shell scripting, plus nicely sorted patches, nicely versioned, nicely available, not downloading stuff from mirrors behind your back and stuff. One of the most nice to read and study, reuse, share, like, and subscribe meta source distributions probably you could hopefully want to work with. Typos, so GCC, so that some of the stuff of course might build 5 or 10 minutes. I think for Itanium it was significantly faster the last days. So for some reason, sometimes also GCC and stuff has some performance marginalities, like here, unfortunately not embarrassingly parallel. I'm spending here already 30 seconds in CC1 plus. And one of those cases, unfortunately, that are not really further sped up. We will, however, vastly improve that next year, probably with better package build scheduling, so that we could already build other package in parallel. Although for the case of GCC, maybe not, but in the case of other packages, like sync minute long running configure runs already built, like not currently, we are limited to one package at a time. And to make even more better full use of epic and thread ripping and Ryzens, even consumer Ryzens, maybe next year probably better multiple parallel package scheduling coming to T2, because obviously we want to cut the build time down further. So here was a typo, there was some characters missing. This also should theoretically only be 80 characters, and so let's trim that a little bit, in my opinion. So for example, C library is a little bit superfluous. So library for multi-precision floating point computations with exact rounding. Where can we further short this MPFR? So C library multi-precision floating point is exact rounding, also called correct rounding. It is based on GMP multiple precision library, main goal, provide library. Quite repetitive text and stuff. GCC is still building. Yeah, so yeah, I think for Itanium, strangely, this is a thing, right? For some RISC architectures, the compile time, more registers, more registers, usually more register allocation stuff, and slower build. So all the build time greatly varies between PowerPC, ARM, RISC-V and stuff. And like Itanium, not only registers, but also instruction bundles, or what they call this scheduling. So although Itanium was faster, so whatever, there's some, I noticed that already the other days, strange performance marginality going on, but this will continue shortly also. Control B. But I think we scratch a library and simply make this multi-precision floating point computation with exact rounding, because all the other surrounding stuff is a little bit superfluous. Who cares if it's a library and stuff? All the other stuff here is more important. So at least we have some win-win of improving our metadata stuff. Fixed truncated MPFR title and shortened to something of that sort. Yeah, GCC is still building. This is why we obviously need more thread ripper. No, we committed this already. Also multiple MPFR. Yeah, also I little yeah, there is no multiple precision. Let's check what they write on. I also find this. No, they have here multiple precision, so this is probably copied from that here. Multiple precision. Yeah, it sounds a little bit, yeah, or so, whatever. By the way, I hope. Yeah. Good, GCC still building. We have theoretically, oh no, I'm speaking about which, so yes, 8 minutes. I think Itanium was way faster for some reason, but whatever. So now we are building cross-build stuff, right? Yeah, also sounds weird to me, but whatever. So now we cross-build stuff, right? So if we would target ARM or RISC-V, now we would get all those cross-compiled stuff. And in our case, we cross-build to the same architecture for reproducible builds and not leaking old libGCC and stuff into the system, which is why I prefer that setup way more anyway. So these are already cross-compiled host libraries like setlib, setlib and stuff, ncurses. Fun fact, we only need ncurses here early because LLVM needs that for command line interface stuff. Also, yeah, some stuff we built again, like previously. All right, also this so this is still a cross compiler. We improved this the last videos. If you're interested in all those details, we had like 4, if not 5 videos last week about the second biggest refactoring of the stuff in the history of T2 and Rock Linux. And so now we build basically live here on this channel since Sunday or so. More full-featured cross-compiler. Previously, this was already full-featured. Like 18 years ago, we could only cross-compile C. Then probably 15, 14, 12 years, probably 14 years ago, so or 16, something of that sort. I had huge efforts already 15 years ago to cross-compile C++, something people at that time also rarely did. And maybe at that time T2 was the only meta distribution build system that cross-compiled C++. I thought this was already amazing until last week when I discovered we can also cross-compile lots of additional support libraries. So now we have lib quad float, lib sanitization, and other libset and this, that, and the other. Also stack smashing, protecting stuff, lib SSP. So since now basically making T2 even more amazing, even more full-featured cross-compile setup, although it was all last week's work, huge amount of work, and increases the build time, of course, but certainly some price to pay for improved features and support. And this is why we built this stuff multiple times, right? We built libxml before, but that was native for the host, and now we cross-compile it for the target to have in the new sysroot. Similar to GCC and LVM, of course. So this is LVM cross-compiled, so that in the case of ARM and RISC-V, we would have that for ARM RISC-V native binaries there in the sysroot for Mesa and so on. So this, of course, also compiled some 8 minutes. We have, so the only, did I cleaned that? Let's see, does it rebuild? We have here some PowerPC 64, actually let's check the log. I built some stuff already overnight. Most stuff should build of all our years of YouTube live developing that here. We have here, however, Firefox. And that failed on PowerPC, most likely due to defaulting to 32-bit. And that doesn't find, so is it RPC, Rust API, Tools Profiler, Rust API build, Rust off, command, failed to run custom command, Gecko Profiler. So I think somehow this doesn't find SUCC standard int, and probably that is due to Clang, maybe for the cbind gen, I assume. Yeah, error. So I'm pretty sure it built also no, we didn't finish VM, but we will any minute. I'm pretty sure it did that because I'm pretty sure it built for PowerPC 64 little endian, and also 32-bit PowerPC. Actually, I didn't want to interfere into the build here too much, also to document the build time of like not wasting CPU cycles and caches. With additional builds, because we would need, unfortunately I don't have the sources here anymore. I cleaned them already away. var adm cache Firefox. This build how long? 5 minutes until the build error from 1900 last night or so. Yeah, from 1908. Most likely we would need to I think I would. Well, it doesn't find the header, and wait a second. should it in any case find the header? So one way I usually do is using strace to trace what stuff it executes, like helpers cc1 and cpp and stuff. And in that case, probably via clang. Also our LLVM build, like 5 minutes 20. And this is also why I fully automate this right now. We can drink coffee, chat and stuff, and look out of the window. Answer customer emails. And it's like why you just want to manually type in all this stuff. And of course, typos, right? Otherwise, if you do this manually, there always will be typos. You forget stuff. I mean, even I can't. I do this for 20 years. I remember a whole lot of effing bullshit over the last decades. But even I don't, and certainly don't want to remember all those configure quirks. And it's like, yeah, because some people always like, yeah, it's boring, lazy, whatever. And automation should look like no automation. Previous video automation is amazing. Automation is king. We even scripted the whole data bot, right? Our Linux version having a data AI bot, nightly testing for updates so that we wake up and have already some latest and greatest package updates for you to play along at home. We can check here in the meantime while we wait. So this is now building Clang again. So that is the native version of Clang. So we would not necessarily need Clang here. We only need the cross-compiler Clang. So we could save a tiny little bit of build time. However, configuring that would be more complex, right? I don't see the point of saving a tiny little bit of my electrons and build time here for not shipping a native Clang. Also, if you wanted to build something natively on your yesteryear's Intel Core i whatever, then like updating Firefox at home with T2, then, or God forbid on your gigahertz G4 or G5, it would certainly suck if you don't have Clang, right? So I save here only some 4 minutes of build time and complexity of configuration nightmare, configuring that explicitly away and making life harder for users playing along at home or a P3, right? And maybe people also prefer Clang for some reason. So even if you're not rebuilding Firefox, maybe you still prefer Clang for potentially maybe at times faster build times or better diagnostics for especially complex templated C++ code. So if you software develop on your SG Octane P3 or latest and greatest previous video, unmatched RISC-V boards, and maybe you want Clang anyway, so that's why we build that. Speaking of Clang, I wanted to check what it is configured with here in the case of PowerPC. And so Clang running that with probably target. What do we have here? Toolchain file, something. Toolchain file, user lib and stuff, release, Clang table again, Clang build static, something. Do we not have, yes, defaults, this default. Target triple, however, is PowerPC T2 Linux GNU. Okay, we default to the right. How do we build Rust? Maybe Rust is then not configured for, which one would we would need that one. Do we work that for PowerPC target? Target, we also work that to PowerPC. Yeah, this is also 32-bit. That actually is supposed, no, then it's not as easy. That looks correct. So it's not the most trivial thing, unfortunately, that I hoped it would be. So yeah, Clang, while we wait for that, that doesn't take, also it doesn't take too long already. Finished. Also new this year in T2, and also the complexity and all the dependencies and trusted code base adding up, right? I'm personally here, recurring theme, huge lover of minimalism, of reduced complexity and keeping stuff as stupid simple as possible. And yeah, nowadays we need not only one compiler, but two, GCC and Clang. We do not need one assembler in binary tools like bin utils. No, we also need bin86 and NASM or YASM. And then doesn't stop there, right? We also need additional multiple languages. I'm not a huge fan of C. In my opinion, it would be fine if we had rewritten everything in a safer language by now. But then we also need Rust, and only in all those complexity, right? We have here configured 300 or so, 350 packages, or maybe 300 about. And because 50 are rebuilds of cross and native, we can actually create error list of a little bit doxes like here, because Vodafone doxes keeps still failing. So 409 builds, and so okay, 409. It's a little bit more than I thought. It probably added quite some dependencies over the year, and this, however, includes some rebuilds, right? So this is builds, but not packages. So this, because some packages are built 2 or 3 times, like Linux header twice, glibc twice, GCC even 3 times, LLVM also twice, Clang also twice, libxml twice. So yeah, so this is probably about, actually we could get the correct number for that. That is everything selected here in config x86 packages, and word count of that is 358. So much to my guesstimate there. And yeah, Rust. And also the improvement that I wanted to mention this year live on this channel. Previous year, integrating Rust and Cargo at all, huge achievement, multiple, probably 10 live streams over the years alone of Rust and Cargo, still not super amazing. Super distribution, non-conforming, non-standard stuff with Rust and Cargo. But now we also cross-bootstrap that so that we have our own freshly reproducible and not cloud-loaded binary stuff, and building that to all our crazy set of supported architectures. And so that is the cross-compiler here. And we also built this twice. So we built stage 1 Rust C as the cross-compiler, similar to GCC and Clang being cross-compilers. And then we use that again to build a native version here in stage 2, native build stage 2 of Rust C. Then in some minute. Also, actually, Rust C will take actually quite some time. I think this is more like maybe 20 minutes if we are unlucky. And this is theoretically, we should parallelize this build stuff soon. The more the better. Speaking of which, all right, PowerPC. So unfortunately, probably the problem is if I now build PowerPC, we can, how was it? Was it like that? I think this was the most nicest something. PowerPC 6432. The problem is now I changed the path config version, so this will start from scratch. So we would need to YOLO that a little bit, which you should not do at home. And change manually change. So you don't do that at home. This is only a pro electron and time and money saving move here that you don't need at home, hopefully. So that should give us actually this can still build quite a bit in parallel, because Rust C at times is also pretty serialized with although can be, but right now isn't, but otherwise it often LTO links also for, I think Rust C LTO links was as complex and monstrous as Rust code already gets these days. In Firefox alone, I think I've seen 6 minutes, right? So no kidding, on a epic thread-ripping AMD Ryzen 1550X, 6 minutes or so linked LTO link time. Also, I'm sometimes thinking maybe I should build without LTO, but here you see, for example, we have only, also yeah, they run here 3 minutes, right? So much to Rust, amazing and stuff, but yeah, 3 minutes 12 and counting, 3 minutes 57. Also, wait, this is probably accumulated parallel times. These are probably algorithms most likely running in parallel. Otherwise, this time wouldn't increment so far. Yeah, they also use 277% CPU load because 100% is one thread, and if you run 2.7 threads, then you get, if you're wondering how do we get 270% CPU load because of that. So yeah, this is why we actually make quite some good use. And previous video, we previously built like 25 architectures in parallel, previous live stream for hours to come. This is why I usually build multiple. Only today I did not do so because I wanted to not only go as fast as possible through this, like epic thread rip through this build, but also obviously do not delay unnecessarily this YouTube live streaming for, yeah, not using all threads and having here background CPU time of that. Yeah, debugging Firefox, that will be a challenge, but as people see, if you are not a subscriber yet, you probably want to share, like, and subscribe to see me usually accept here all debugging challenges. So debugging the stuff, for this stuff, you certainly, yeah, the more experience, the better. But this is also full stack, right? We're currently working on everything from compiler, C library, kernel, and libraries. And in 20 years, you have seen a lot, and everything you have once seen, you can't unsee, unfortunately, and everything helps, of course, debugging this crazy stuff, because actually, so Firefox is using make files and configure and mach and all kinds of build systems and cargo, and then you actually need to debug through all of that and see what it's actually doing there with Clang and cbindgen and Rust and cargo and whatnot potentially. And this is why often these days I simply start throwing strace onto this, strace -f follow forks -o log, and then see what is the last executed thing, what did it try to load, like it doesn't find some C headers, and then figure out why not, where are they, where does it look, where does it come from which build system, metadata, mach, Rust, cargo, surrounding, toml, YAML, whatever, metadata scripts and stuff, and then see what's there. Theoretically, if we wanted to be pros, we could add that to the to-do here. We basically have Spark 64 grub 2 stone module that still is a thing on PowerPC 6432 Firefox. I think that mostly is the big stuff currently, probably. Firefox still going there. And Firefox. And yes, so Rust. If you build a Linux distribution, it's probably you simply want to use T2. You obviously, the faster the better, faster CPU the better. Rust C. So what is our, so yeah, some of the stuff are rather time consuming, which is why usually we don't live stream all the build, but more working on stuff like this Firefox stuff. Actually, I made the recurring beginner mistake of cleaning. Actually, when I started the live stream, probably I had the source Firefox there. I didn't really think about this anymore. So I made the recurring beginner mistake here of cleaning that before the live stream. It's like, yeah, just wiping that to build it again. Periodic 22 writes new linker might be interesting, seems a bit faster. Which linker is the LVM one? We also packaged mold, yet another allegedly blazing fast linker yesterday here. So that is the stuff. Also, if you are into T2, because you obviously want to run it on your P3, on your Xorg or your unmatched RISC-V board. Previous video, right? The only one in the world running this with an RDNA 2 CPU here, a GPU, because obviously, and you miss some packages, just package it, right? Metadata a little bit. Maybe I need to make another video, otherwise it is easy. There is a handbook. Just open an issue, attach the patch, send it to the mailing list, Discord, or in otherwise me or something of that sort, and to package the next big package things. Yeah, Rusty. Also, I mean, the load is though 21, so also we had the Rusty was, I think Rusty was using 1000, I think I saw that briefly, 1300, yeah, 447%, apparently also 800%, 8 threads, apparently quite parallelized these days. Rust cargo, there we have it. What do we have? Rust, here, so this failed as expected, and let's see if we can, in nothing here like on this channel, running the wrong commands here also on this channel, nothing like, all right, this is nothing like debugging some complex issues. That was it built? Let's double check, not that we ruin our, yes, I know. Also need to configure my Vim better not to cause a sandbox violation. Yeah, mach build. All right. I mean, we could, so to minimize random, also yeah, nothing like recurring theme here, huge fence, not of Rust and cargo micro dependencies. So was this an error? I saw there's something. Was this error or unknown? Here was something. Unable, here's probably, that is probably, this is most likely a main panicked at unable, exactly what we're looking for. So C standard int file, not for, I mean, it's crazy, right? It's also the complexities of modern recurring theme here, recurring critical thinking and critical criticism. In my opinion, not amazing that we need two compilers, multiple assemblers, linkers, languages, and this for Firefox, right? Okay, if we wouldn't use GCC as system compiler, we still would have Clang and Rust. Now we have Clang, Rust, and GCC. Okay, but yeah, more languages and more, yeah, not single point of failure, multiple points of failure, right? Who is surprised? I wonder, did this support J1 or something? That would be interesting, potentially, to keep our S tray smaller. Yeah, this is already here. I think S trays log. I don't think Clang and Rust look like they are configured for 32-bit. What could possibly go wrong there? So warning mem copy, nothing like some non-trivial stuff of buffer overruns. Of course, running this stuff through S-trays really, okay, there we have this Control-C. By default, due to the nature of this complex build systems, it would run a little bit longer of parallelized stuff and so on. But of course, we don't want random garbage in the log, so the sooner the better. So this was, what was the header? I think it was something like C std int, or what did it complain? C standard int. and it actually standard int it's probably so the problem is with the threaded and multiprocess stuff, there are a lot of unfinished things that are restarting here in the STRS log. That is of course highly unreadable, which is actually why I really try to run this with J1. So here's new FS. So here it's trying to do that. Okay, here also on our main build, Rust finished. So continuing, this files is a T2 specific package. Distributions often have something like that. This files is like etc issue or other random miscellaneous support files and stuff. mk-initRD, the initRD generator distributions have usually their own package, so this is unique to T2, libatomic ops for atomic operations, automake, disk type, gzip, the GNU set compression stuff, mbutils we only use for slightly smaller initRD. We would not necessarily have that, it's tiny little of also mini SAD, just for really, I mean actually I could theoretically change the default build not to do that, but on the other hand, it's just 3 packages, so it's like, yeah. CPI also, again, some of the stuff we built previously, and this is a cross build now for our intended target. PDKSH, you might wonder, crazy complexity. We have 3 shells, I think, in the default install. Bash as main T2 scripting, born again shell, of course. Then recently Dash, because I figured we benchmarked this previous video. This is the crazy stuff we otherwise usually do here if we do not watch our distribution build. We benchmarked this. Dash is mostly enough compatible as system shell, and that greatly sped up configure time. So we run this only since a year as a default shell, and this, yeah, certainly 11. I think it was like 11% or so, 10 whatever, 10, 12%. Faster configure time, certainly, with all the CPU cycles otherwise wasted on epic thread ripping AMD Ryzen and stuff. Certainly welcome. And Dash, unfortunately, is not full-featured enough for the advanced substitution we use in the initRD. So unfortunately, we still have PDKSH. I tried. Maybe I should try harder to get rid of PDKSH in the default build just for our initRD. I would otherwise use Dash, and again I tried, but it didn't. I think it didn't hit like / regular expression or wildcard. Or it had, maybe it was actually double bracket wildcard matching. Some of this sort it didn't support. Maybe I should check. Maybe I should patch it in. I don't know, but that is a little bit sad that even ourselves, we have 3 freaking shells. I would love to only have 2. I mean, I would love to only have 1, but I understand that some 10% faster Dash is not full-featured like Bash. So, and Bash we need for our own T2 scripting. So 2 would be fine, 3 is a little bit excessive. But it's also, yeah, that, I mean, sure, it is good you have so much choice, but then the choice is full-featured, medium, not full-featured, and abandon old stuff. So here, the more dependencies, MPFR we had already, otherwise ISL for modern loop optimizations, so manipulating sets of relations, so integer points, MPC, C library for arithmetic high precision complex numbers, and then of course GCC. So GCC we built 3 times, so that is a Canadian cross. First we stage 0, and until recently the only cross compiler. Now stage 1, the more full-featured cross compiler, and now the new previously stage 1, now stage 2 with a now also even more full-featured Canadian cross build compiler. So that output would be for ARM and RISC-V for the target system. And then the rest of the build actually goes pretty fast, except Rust again and Firefox or LVM, all the big packages, GCC, LVM, Clang, Rust, Firefox maybe 15 or so minutes, also Rust maybe 15 or so minutes on a Ryzen 15 or 50X with liquid cooling, Debauer offset plates, and building in TempFS and all the performance optimizations. Also booting with mitigations equals off because obviously feeling lucky and need build time. So GCC, that again will take some 15 minutes, so we have 15 minutes to guru meditate about our build error here. We could, so this is already running in multiple processors. Maybe this one here, there would be, this is also probably best, where's the exec that, or, yeah, the log so large, even epic thread ripping. How do we best, are the spaces or tabs? Nah, even a pain to find, oops. Somehow the grep search also could be faster. Maybe I should profile optimize that better. Oh, why is this not better readable? I would have expected some fork or exit or stuff over here. What is, but as it is not, can't even, okay, maybe we, this is a bit crazy. Should this not be in equals? Should this not be the process ID? But apparently, oops. No. Here, clone 3 resumed. But even that sucks because all this resumed stuff. Thank you very much. What the freaking heck is even? Yeah, so that is, I know why I run this with -J1. Yeah, I rest my case, I think, exec. That is one of the most unreadable logs I've, also I wanted. Okay, Ccache we don't even want. Why does it even try that? What is that? Cross CC something something AS. Thank you very much. So where would it, what is that? C1. So stuff builds. I mean, yeah, so basically the log is too large. Maybe we would, so yeah, even if you astray that, it's even at times challenging to decipher. That so J1 doesn't work here. Thank you very much. Okay, we have run. Okay, now we ruined our log file. So this was C standard int. So what would it? So this backtrace looks like Rust. So the question is, or is that cargo? Is cargo out there? Gecko profiler, is it? Probably should be this one, shouldn't it? So because it says processed and exit successfully is Gecko profiler. Now we would need to take a look what. So yeah, bind gen flex. I mean, we probably, which Clang? Okay, this Clang. What would Clang do when we ask it to build a binary? That works. to some degree. It is defaulting to the correct 32-bit PowerPC Linux emulation mode. It also looks like that would find the headers there without any problem. So we wanted C standard, or not we, they wanted C standard int. So maybe they tried to run it. With custom args, yeah, so that works as C standard. All right, this is or is it standard int? Oh, wait a second. This C standard int is a. Did that even work? That is actually a C++ header. Does work also, doesn't. Also, I wanted. Did I even test the right file? Oh, look at that. That doesn't find that though. Interesting. Okay, so Clang probably doesn't find this fall, which, oh, by the way, which is. That is the right Clang++. Okay, that is at least easier to debug, because now we have a nice reduced test case. So where does it look for that? It is looking in, let's see, did we, wait a second. Oh, we didn't run with. So it tries, okay, user include, okay, this is probably last resort fallback, where is the beginning? Clang include PowerPC wrappers, thank you very much. Local user, why does it not? So some questions would be, among other stuff, why does it work for other architectures? I'm pretty sure it built for other architectures. User local, user include, where do we not have this? Looks okay. I mean, at least we know where we need to look for. That is already something. And while we were meditating over this stuff, we made here some progress. More stuff. So that would include, where did we, here, probably GCC, how long? 8 minutes, so that is the same build time as previously. And then M4 GNU macro preprocessor. Actually, what does it precisely stand for? Just M4 macro preprocessor. Autoconf, the good old-fashioned GNU, I guess, based build system stuff. Is it GNU yet? GNU 2 for automatically configuring stuff. I said multiple times, somewhat of a historic relic. Previously, why did they created that like at the end of the 80s or 90s or something, and to support all those different Unix systems that nowadays nobody's using anymore, like SunOS and AIX and SGI, IRIX, and all this fun stuff. And so now it's only an historic unreadable cluster F of a burden to debug, maintain, and support, and usually causing random build errors on Linux, right? So something supporting like 99% supporting random abandoned vintageware, retroware from the past is causing 99% of the random build errors and hard to debug stuff nowadays. So amazing stuff. I understand why we have CMake, Meson, and Ninja and stuff, just that they are not that much better than that. But yeah, here we have that still. libtool, similar stuff of portable linking, also 99% complexity for 99% random build issues for 99% not used code for Sun OS, Solaris, AIX, and all the other crazy features and bits and pieces like IRIX. Then NASM again, readline, strace, what we just use for system tracing, libaio. Actually, I think nowadays we want, it's a little bit superfluous, right? This is kind of stuff. Could we delete some dependencies, but probably, I think I might have recently added that for something, maybe as something as RxVT or lib event or whatnot, because not that much stuff is using that, a little bit outdated, never as popular asynchronous IO library stuff. expat, GDBM, some database stuff like lightweight in application database stuff used by some stuff like Perl, Python, and so on. Tech info again. So this is cross-compiling this stuff. Like again, some of the stuff is previously seen, but no, sysfs utils, for example. So this is nowadays all this. I actually wonder why we built that sysfs utils. Some of the stuff even I don't remember for what we added that. But probably there was something, probably some rare stuff. Sometimes also like stuff like Firefox or Meson needs some, I'm not saying that they need that, but just saying sometimes we have some random dependencies for just this optional dependencies that always occur. Time there, what else do we have? Oh, we scrolled already a little bit further. Where have we have been? We have actually quite, while we were talking, quite some, the Ryzen epic thread ripped through quite some other stuff. File, for those who are new to the stuff, file a file identification utility. It has a huge magic database with quite complex encodings because the magic can be in the beginning, can be somewhere else, can be at the end. So it has lots of custom file program magic kind of domain-specific language and database with this stuff. libpng, of course, for the PNG or ping image file format, libffe, foreign function interface. Also nowadays, yeah, foreign function, this means foreign function means for other languages interfacing, usually C or vice versa. So a lot of the stuff, for example, some VM like LuaJIT or Rust and so on, or other, maybe even, I think even as crazy as it is nowadays, glib and package config for GNOME, like GNOME Valor and other JavaScript and surrounding stuff, needs this at times to interface C, like usually like portable written in C, smallest common not denominator there, for interfacing like lib, setlib and libpng and stuff. Free type, again, this time the cross version. Previously we built this already for probably grub themes or whatever, and now so basically stage 2, this is building all the stuff once. This is basically the main stage where 90% of the stuff is built. Find utils like GNU, find programs surrounding find, diff utils for diff and patch and stuff. The Unicode string, again, lots of the stuff thread ripping through the stuff in 11 or 29 seconds, which is also why you don't want to manually type that and fully automate that, because obviously you type slower than some of the stuff builds. Patch, make, the GNU make implementation that we use for most stuff, grab the file, searching text in, data streams, lib pipeline, of course, stuff scrolled even more. BC binary calculator, power compatible regular expression, PCRE, JSON, C implementation for JavaScript object notation. What else did, so also stuff that scrolled by is the pipeline. Not sure for what we needed that, but probably for, all right, we needed that for the latest man page update nowadays, 2021, needing the pipeline. The GNU stream editor, SED, used for scripting and automation stuff, LZO, small. Also, I think some of the stuff maybe LZO we could delete, that was previously fast and small compression library, nowadays mostly superseded with set standard, as in also fast, because previously setlib and bzip2 were so slow. Nowadays set standard is so fast, you often use that at times, because with set standard you have the choice between fast and super most compression, and LZO is only fast and doesn't have good compression. So yeah, tar, GNU-org, the scripting language. Yeah, obviously you need many scripting languages to build your Linux or Unix system. bzip2 compression, LZIP, some of the stuff we could even probably nowadays not include bzip2 and LZIP. I also only recently added LZIP because this is mostly as a convenience for people playing along at home, because if you install T2 on your P3, that you have them, because some downloads, if you emerge stuff from original upstream sources, some stuff still bzip2 or even newly LZIP compressed. Xset is some of, again, Xset just random convenience for you. Less Graph, Graph is the GNU Graph document formatting system for man pages and stuff. Here's the man pages. Kmod, the previously module init tools, now Kmod. Module loading, xxhash also new for rsync and some maybe even GCC or otherwise hashing of mold linker hashing stuff. Bison of parser general purpose parser generator. JSON C we just saw. BC binary. This is numeric processing language and calculator for arbitrary also precision. Util-Linux, Stone, our setup tool 1, libusb. You see this all this non-rust and stuff, epic thread ripping pretty quickly through all the stuff, 1 hour 30. Also, yeah, basically, sometimes people don't believe me that T2 is so optimized, so amazing, and automated script and stuff, that given you have enough epic thread ripping AMD Ryzen CPU, that you can cross-compile a whole minimal desktop and Firefox system in just like 2 hours something. Basically, a live stream also not only educating and entertaining you, but also documenting that. PCIe, Util-Linux. Yeah, Util-Linux, Linux utility as the name applies. PCIe Perl compatible regular expression library to use Perl compatible regular expression from C. Bash, the GNU Bash shell. MT-dev, multi-touch device stuff. Also a relatively new package for multi-touch device support stuff for Xorg and Wayland. ED, the ED editor. Then yeah, we had this already, Cargo and Rust. So this is previously we built a cross-compiler. Now we build the target Rust. This is why we, similar to the compiler, need to build this twice. Cargo we only built once though. So what's going on here with giving us, after shouting this out, a quick, probably 15-minute or so guru meditation. Cheers. For what's going on with this header stuff. I slightly wonder though, which other builds do we currently have? We should probably have, no, clean, where did I, oh, this is also the wrong directory. Hello, I deleted that. Doxys, cable, previous video, Vodafone, not recommendable. So clean build, so let's hope we have another build. Yeah, risk 5. Probably should have Rust. Toolchain, tools, cross, bin, clean, plus. test cc exec format error. What? Oh, this is a link to Clang, okay, but can never have enough. That is 64. Why? What have I done wrong for that? Maybe it just. What is it trying to execute? I want notification. We had some outages. Do we? Not sure what happens there. What did we exec? RISC-V bin LD. Actually, you know, why does it? That is rather. What does it do there? Build. It tries to run the native. Okay, not sure if that is really what should happening there, but that's not our topmost concern right now. I think otherwise it looked like it would work in other circumstances. But so that works crazily enough. See standard int. So that is actually indeed loading the libgcc. Why would it not do that for PowerPC? So we have here our user libgcc target of RISC-V, and what does it do for PowerPC? C standard int. It tries PowerPC wrappers. Why did it also do tools? Did it start also super efficient writing one character at a time? Tools, deploying PPC wrappers. Why would it do that? Why would it behave slightly different for? I mean, we could, for example, grep for PPC wrappers. Maybe it doesn't. Also, Rust already built apparently. Did this build faster? Maybe it built faster because the Canadian cross is 6 minutes. Was how long ever the other was, but 6 minutes 50, not too bad. Maybe this is building less interim native bootstrapping stuff. So unzip, zip, again, just for stuff like Firefox and so on. ALSA libraries, advanced Linux sound architecture. Nowadays, of course, that is not enough. You also need Pulse Audio Pipewire. ALSA utils for mixer control stuff, for the init scripts and so on. glib, the GNU, GNOME, and other nowadays surrounding everything C support library. glib networking we need nowadays mostly for WebKit GTK or other GNOME stuff. Our ROG Linux inherited ROGNet package config, the package configuration include file and library, tool glue, half-bus, more text layouting, libgpg, libgcrypt for alternative. OpenSSL is not enough. Alternative crypto stuff. libxslt for XML style sheet transforms. fget mostly for network booting for our installer. Small little HTTP and FTP helper stuff. Then nowadays the Wayland stuff, Wayland and protocols, and then plenty of Xorg event. And yeah, nowadays, previously, like 15 years ago, we had X386. Nowadays we have plethora of not only hundreds, not only dozens, but 50 or so small little Xorg proto, Xtrans, and surrounding libx11 packages, all of which are thread ripping here in like 4 seconds or so, 4 and 9, and even XCB protos is like 2 seconds. We got that. Lib event dev is basically Linux event device development library helpers, of course for C, as much as we don't approve of that here on this channel. libxcb, the new, more modern X interface. C language binding library, xdmcp for DMCP, support in the X server for sync display, whatever precisely this was. Anyway, it's scrolling pretty fast, but not anyway. libx, so this is extended X stuff, font encoding stuff, good old-fashioned bitmap fonts and stuff. XCB util. So some of the stuff is only optional extensions, some of which we only need for Qt or Firefox. This is why we built a little bit more than super totally basic, just to have Wayland and Qt built out of the box. libxt is super old-fashioned X toolkit stuff, similar to libxmu of this is funny also, of miscellaneous utility library, libx Athena widgets or so, X fixes, because you obviously need fixes to your protocol, then 15-year new composition and X render extension libraries and protocol stuff, and also damage, right? All those composition stuff only 15 years in the making. New there in around 2005, similar to colorful X cursors, previously black and white, nowadays full RGB color cursors. libx font libraries and 2 font caching, obviously, because caches are always faster. libxft of X font rendering technology and stuff. libxi for X11 input extension, Xinerama. Probably we could cheap out of not building some of this Xinerama stuff. Probably very few stuff still needs that. But basically it's also not really worth my time to go. If some of those old dependencies triggers you and you think it's 2 seconds build time and probably 200k also in our ISO times, and just send me a list of what you think it's not needed. It's already pretty distilled down, but there probably for sure is 1 or 2 or maybe even 3 that we do not really need. For example, make depend, maybe we don't need that. I could check another day. This is basically old-fashioned. 20 years ago, right? Of course, X386 as a major project needed their own build system and make file glue. So yeah, xbitmap, font util, libdrm of rendering, direct rendering, manager interface library, libva for video acceleration, libvdpau for alternative video acceleration, video decode and presentation API, dbus for that old-fashioned, also in the meantime old-fashioned protocol stuff, 15 year in the making. Also needs this for rare stuff like pulse audio and pipewire and stuff. Wayland protocols, dbus, glib for glib bindings for dbus, mk font scale for those old-fashioned bitmap scale directory stuff, bd bitmap font to PCF encoding and utility stuff, font aliases, so basically some miscellaneous font metadata, most minimal needed to start in good old-fashioned X protocol. stuff here, like ith, auth, and RGB. RGB are ironically just some RGB definition files for your Xorg server to start and some X resource stuff to work. TWM, XAuth, XConsole, XCursorGen, XDPI info, because certainly that is nice stuff to have. XEvent, XHost, XEnit, XKB common. And by the way, it still triggers me probably sometime soon. I need to include here some percentage counter, because even for myself it would be nice to know how many percent we are through the build. More XKB commons, XKB com for X keyboard definition compiling stuff, XKill, X magnification. Again, we don't really need XMag and stuff, but this tiny little stuff of building in 1 second or so, not really worth not shipping. So if you wanted to do some X magnification class stuff on your fresh PS3 or Octane install, then you have that. XZ pointer, XZ root, XSM, XWin info. Again, all the stuff not really necessary, but yeah, maybe nice to have. Xcursor theme, libjpeg now, libwebp. Libwebp also only new. I think we added that for WebKit GTK recently, but certainly also nice to have some advanced image compression, decompression codec support on your fresh install, like libtiff, the tagged image format, C standard support library, libti, RPC for NFS mounts and stuff, dialog for some scripting fun out of the box, PEM, the pluggable authentication module for your fancy login support, infrastructure stuff. Mine, our soon to be replaceable binary packaging stuff. popt for you can never have enough C parsing. And popt I would remove. I think I tried to remove this. I only had to read some random stuff needed that. Yeah, so yeah, C is so amazing. You need some argument parsing support stuff. Obviously, Netkit base for ping or so, maybe other surrounding stuff. libpcap for package capture, API Apache portable runtime in our default installation only for Subversion, API util similar there for Subversion, rsync obviously, who would not want rsync in your default install for quickly remote syncing some files, KBD, the Linux console, probably only used by you and me, and otherwise most people of course using X, but otherwise that would be for the Linux virtual terminal keyboard mapping stuff, SQLite, nowadays mostly for Subversion, and Firefox if Firefox doesn't build its own. Yeah, the new recurring illness of big mega projects coming with their own bundled third-party copies, so I'm not even sure. I would prefer if stuff uses system libraries for only one system library update at a time. libtasn1 also there, libsnd file for sound stuff. I think libsnd file, do we have that only for maybe Blues utils for Bluetooth stuff, or WebKit GTK or something. Lib international tool stuff, X keyboard config for more modern. X keyboard metadata, shared MIME info for this shared desktop environment, MIME info database handling, libmet of an MP3 encoder. Not even sure why we maybe for Bluetooth or maybe for Bluetooth MP3 headset. Share, like, and subscribe for review coming up. Headset support, libopus for this open source video. Also there was libOg already scrolling by. Yeah, OG and Vorbis and Opus for this open source royalty free and patent free audio stuff. CAPS, the common Unix printing system. Little color management system, then Bitstream, Vera font, scrolling through free, just some basic free font support. USB utils, so that you have LSUSB and stuff out of the box. Help to man for some random packages probably needing that to build their man pages. Flag for that. Flag was this, yeah, free lossless audio codec. SBC for the small bandwidth, also codec for Bluetooth. fame, so that all your random Bluetooth headsets work out of the box with that. Actually not very good, but small bandwidth codec Cairo for that. Vector canvas rendering and C support glue library GTK talk for a lot of packages needing that, unfortunately nowadays, otherwise they might not necessarily compile, or otherwise RRG streamer for that. Multimedia stream handling stuff, we need that mostly maybe for Firefox, but also for WebKit GTK. PCI utils, so that you have LSUSB and other such command line debugging utils at hand. UDEV, of course, for the user dev in user space stuff nowadays, otherwise also in systemd, but we prefer systemd less. And UDEV you need otherwise for a lot of Xorg and what else was it? Yeah, Xorg and Wayland, and lots of stuff needing libudev, also certainly, you know, lots of KDE and GNOME stuff. libvideo for Linux for this video capturing API for your webcam capturing and stuff. Netlib for another, I think this was low-level cryptographic library designed to fit easily in many contexts. Curl for actually, so I always thought C stands for C, but this is apparently just client library for HTTP, as maybe even FTP and stuff like that. Also, of course, used by other packages. Also here on the command line for T2, but also other packages. GNU TLS for this alternative TLS implementation, because due to security and stuff, you can never have too many of those. FreeBD for another text handling library for bidirectional algorithm library. Then the modern Vulkan headers that we nowadays also cross-compile, obviously. libx shared memory fencing. libelf, ironically, libelf is one of those libraries. You would think with bin utils and stuff you would have this, but no. Also, I wouldn't necessarily ship this. We only have libelf for the Linux kernel of all things. So the Linux kernel doesn't build anymore because of all the security mitigation, trampoline and other object hacks and features. Performance optimization is quick. So the Linux kernel needs for its object mangling and stuff tools libelf. So this is why we need that. The Vulkan loader matching to the Vulkan headers, and then Mesa gives us a minute to guru meditate of Aurora. So this would be probably Clang of still need to debug that here, and yeah, Mesa built some minutes for that open source. Previously GL, but nowadays also Vulkan and surrounding infrastructure, including video encoding and decoding, like hardware isolated on chip, on SOC and on GPU, as seen previously here on Linux and OBS live streaming, and similar such. Also, yeah, hardware drivers and also software implementation as SoftPipe and LavaPipe and Sync and stuff. So Clang, did we? Also, I did not press enter twice. PPC wrappers, where would that be? Just figuring out where that would be coming from. So maybe we don't patch this tool chains enough, because I think we patch this, or we don't patch PowerPC Linux. So hello, did I? Oh, this is also tool. Did I not Toolchain that? Oh, hello, Toolchain. This is PowerPC Linux here, probably for. Okay, we will see in a second. Okay, Mesa built already. Epoxy for that, I think GL also, yeah, OpenGL function pointer management, because nothing like some additional management library for your complex C API. Xorg server, of course, a good old-fashioned, hated by others. I don't hate it as much, although I don't like C and security vulnerabilities, but otherwise certainly like supporting good old-fashioned protocols. So yeah, that is that. But something scrolled by. libinput for this model input handling. Then XF86 That, by the way, comes from X386, for those who didn't know that, of good old-fashioned X386 API fame. Keyboard, mouse, yes, old-fashioned support compatibility glue libraries. Nowadays, of course, mostly FDev is used, but otherwise also device-specific. AMD, APM, we basically build all drivers that hopefully maybe still work. We also did low-level code here live on this channel for Verge, Voodoo, Matrox, Imagine 128, Link 3D. So we will continue with that, right? So 2022 resolutions here, more microkernel, more low-level code. So we will actually implement modern support for lots of these chips, of which I have a huge stack in the office of archiving hardware fame there. And in the case of Link 3D, the first open source code ever written for that. And we also previously already 2 or 3 plus years ago, if not 3 years ago, took a look at the one of the first 3D accelerators, not the Voodoo, which we did also, but the rendition verite of the first fully flexible RISC programmable GPU accelerator, which I also eBay auctioned just for this live stream video stuff. And eventually we will also, in the next years, maybe not next year we will do, we will for sure will do some new low-level code, maybe early, so probably continue, maybe some NVIDIA and ATI, that probably is the most useful. So, and maybe also early Intel also, just because we will, 2022, the year of our microkernel, and certainly we want some demos. And I said this before, I will kind of create some Rosetta kind of code library stuff for not only our microkernel, but also nano kernel hardware abstraction layer. And I want to structure it so that this low-level code of drivers of Verge, Voodoo and stuff can not only function in our microkernel context, but also Rosetta code, meaning being able to build that for multiple targets, including low-level, aka DOS, for example, demos, so that having one future maintained code base that you can also use for your own kernel experiments or DOS demos if you wanted a hardware accelerated Voodoo or Verge demo for DOS, for example. Lots of other stuff scroll by while I tease that, for which you probably want to share, like, and subscribe, and Patreon, GitHub, not only for our Linux maintain ship, but also future low-level code, FPGAs, and microkernel to come. So a lot of drivers scrolled by. AST, we had ATI, a dummy driver, which obviously pretty useless. Cyrus, which is also BOSS and QEMU emulation. Glint, i128, for which we wrote our own code. Intel, the first Intel dedicated video, i740, ATI Mach64, Matrox MGA, Neomagic, Novo for this NVIDIA, not infamous open source, basic NVIDIA stuff. OpenChrome, R128, S3, Silicon Motion, SES USB, stuff probably very few people still use. TDFX, Trident, video for Linux, VESA for this unaccelerated mode setting stuff, VMware, and now comes ATK for this assistant technology, ATSPI 2 core for this newer GNOME assistant technology, also stuff, FreeGLUT, and also some file system tools like HFS utils we need, for example. You might be wondering why we build this. Theoretically, we could disable that for x86, but for PowerPC, we need that for most likely bootable file system wrapper creation for PowerPC, mostly popular on Apple hardware previously. That is why it is in our default build, a little bit superfluous for most of the architectures. I could actually make a note of maybe not building that by default, but again, maybe it is nice to have them where here HFS utils only for PPC, maybe in the future or something of that sort. But again, doesn't hurt much, and you can MK HFS on your x86. Lestiv, Glue, Xterm for this basic X terminal. So what's going on here? Include, this is all, this is interesting. This is only PowerPC target. Do we have this, do they have this for all RISC-V toolchain? What was the, do they have a little bit extra handling for AMD GPU wrappers? Thank you very much. Maybe some special PowerPC Linux handling is breaking that as it works for everything else. Why do we have PS4 CPU? What the heck? How many Linux? So maybe some, okay, we have MIPS Linux, so we don't have Linux for everything. So maybe some special PowerPC handling, maybe some embedded. MIPS is also a little bit more. Yeah. This looks strange, and this is my recurring grief. Previously not so most impressed by the LVM client build system stuff. I always wonder that such high-profile packages have so strange build system glue. We are, by the way, coming to an end already in 1 hour 50. Yeah, so 2 hours. So we have now long but embarrassingly parallel packages. We had here GoScript, so this scrolled by fast. Where's our, so yeah, less diff for this old-fashioned motif. And also less diff we only need for some, I would normally not include less diff, and that is only like for Mesa demos, for GLX gears or something, as crazy as that dependency chain is. Glue for this open source extension wrangler library. Xterm, we had libpty, TTY stuff for RxVT Unicode. Then RxVT Unicode, just because this is we have a minimal Xorg and we have a minimal desktop. So the minimal desktop is mostly Firefox Plus, a little bit nicer to have than TWM and Xterm. So that's why we have that here, like black box. X Composition Manager, libicl we only have here for the WebKit GTK, for the platforms where we cannot build Firefox, we can build it, but it's segmentation faulting or otherwise not working well enough. So for those we build WebKit GTK, and for those we have no, this is untrue. Libicl is shit, I tell you. Libicl is actually for blues, because that is a, I think, hard dependency. At least I didn't look closer. Sometimes it's not the best of my time to investigate how much required is it, or can we patch it away? Something like, yeah, just build it. Because blues, since whatever version needs libicl, because obviously it needs that. scons, just so that you have it in your PS3 and SGOctane and RISC-V system to build straight away. Serve for that, I think Subversion needs that. Yeah, I saw previously Subversion used Neon, and then they migrated to Serve for performance and whatnot and stuff, and now Serve is also abandoned vintageware, unfortunately. This is a little bit, yeah, having abandoned vintageware just for Subversion. Maybe we should ourselves switch away from Subversion. But anyway, libcap for that capability library of POSIX, getting and setting POSIX capabilities, X264 for that popular video codec, GoScript and fonts for this open source PostScript implementation that you probably need for quite some stuff, and printing, libevent library, high color icon, default theme, infrastructure, glue stuff, libpsl for that C library for public suffix lists, whatever that was. I forgot. I don't have here more. Now I'm curious. Let's dive into there for... this is TLD, global and local domain handling stuff, of course, because it is. GDK pixbuff, pixel handling there. Pango for that, of course, even more font. Layout and rendering internationalized text, handling GTK plus for this popular but otherwise popular, personally not the most popular because written in C, but otherwise of course needed for Firefox and stuff. Pulse audio because it is also needed for Firefox, for me personally, Alza would be enough, but otherwise another C infrastructure layer of handling more advanced, transparently multiplexing multiple sound devices, mixing this in user space, and transparently Bluetooth hand-off and stuff like that. Wireless tools, so that you have this old-fashioned tools for command line handling your wireless stuff. And now Firefox. Firefox is one of the last packages. After Firefox which of course builds for like 15 to 20 minutes or so on a Ryzen 5950X with performance boost optimizations and boosting too. I think maybe the heating is maybe too much turned on in the office, because I have the feeling that it's too warm there for how cold it is outside. But because once upon a time it was boosting more. But anyway, yeah, 5950X software as complex, needing multiple build hours. How much is it? Yeah, embarrassingly parallel threaded to 32 threads. I think once, whatever the total accumulated wall clock time was. After Firefox, we for that popular open source browser, we don't have much, mostly the Linux kernel, and then we are done with our Linux distribution in 2 hours something, and that is why you want to most automatedly scripted build that, cross-compiled for 25 plus and counting architectures. I hope you enjoyed this already and learned something. Don't forget to select and subscribe, obviously. Nothing like watching my own advertisements, also with the wrong account here. So yeah, I hope you learned something. Don't forget to select and subscribe if you want to support our 20 plus years of collecting all this metadata, patching, quirking, supporting compilers, C libraries, and all this hardware architectures, testing that, implementing new features, performance optimizations, just the last weeks here, and cross-compiler. There's Patreon, GitHub sponsorship, YouTube membership, even OnlyFans and GoFundMe. It would be amazing if you do also just some super chat. Everything is highly appreciated, because as you see, even then at the end, there is still strange stuff. What was it? PowerPC, Linux. What do they do here? Of clang system, include and arch. What do they do here? Path appends. If driver has args, no standard includes. What do they do here? They have here clang driver options opt. So if not, no standard includes, and not no built-in, then system path append PPC wrappers. I have no idea for what that is. And we don't have that for most other. Do we have here? This is kind of stuff someone added some crazy shit. No, it doesn't build for us. So they have here Linux CPP though. So yeah, some guru meditation is unfortunately in order here to find out why this is going wrong. Maybe we should have, actually we patched, I think we patched some, maybe we don't patch that enough. GCC path is here of, okay, we have GNU here. Do we not have PowerPC? We have here PowerPC, PowerPC T2. What do we remove? PowerPC, or do we? Oh, we have PowerPC T2 Linux GNU. Is that not, is it something we search or not? And is it something that exists, or do we have PPC? We should have probably PowerPC 6411 for this test build of what do we have here? Okay, we don't have that, maybe. Interesting, do we have PPC? What do we even have? What? Oops. Okay, we have PowerPC 64. Maybe that is the issue, that we have a PowerPC 64 build, but default to 62-bit, and maybe the fix for that is as simple as, although it oh, wait a second, all right, that is a little bit, wait a second, okay, that is indeed a little bit of an edge case. Where is our PowerPC? We could simply, yeah, so because we built for PowerPC, so yeah, we built for PowerPC 64, where is even, here's a little Indian, here is 64-bit, so I think we could simply YOLO that for also, yeah, what would be the best fix? Poppy triples, oh, where does it also use that for, wait a second. So yeah, this is why I never was a fan of this huge hard-coded thing. I pointed this out already multiple times. In my opinion, it shouldn't be as hard-coded as that. We patch lots of stuff away because it makes more sense for us to search for all those combinations if at the end they don't work anyway. As they probably randomly try, not randomly, as they simply linearly try those, and in my opinion, they should be configured once, or even if Clang is not the primary compiler. Previously, 10 years ago, I patched this actually by running gcc at build time and grabbing and SEDing that search path out of it until they replaced that with this huge boilerplate of a hard-coded file, which in my opinion really doesn't serve the advanced LVM Clang, otherwise amazing framework infrastructure justice, because in my opinion this is a really low quality mountain of a mess, of a hack, messy hack. And if LVM Clang is a primary compiler, so yeah, either configure detect that from your primary compiler, and if LVM Clang is supposed to be the primary compiler, just use the configured default host triplet and not this random kind of thing here. Rust tackles it a little bit differently. I would actually say, last but not least, do not hardcode all those random maybe existing like MIPS, ISA 64R6 Linux GNU ABI N32. Seriously? Yes, I know what it is for, but seriously, there is a limit. The Rust people don't do it amazing either, but at least they simply say, okay, you know what, go to hell with your host triplets. We only support unknown Linux, although maybe they should have called this generic Linux, but I understand where they come from, their unknown stuff. So for Rust, everything is simply ARM to RISC-V, unknown Linux, GNU, and it's like, yeah, if all of those vendors like, yeah, seriously, we don't care whether it's SUSE Red Hat, Gen2, Arch. At the end, in some years, sooner or later, everyone is using T2 anyway, so just CPU stuff, unknown Linux, that's what you got and you can work with. So let's see, x64 defaults 10th, wait a second, here's also, by the way, 64-bit compiler which defaults to hence PowerPC user. Okay, so they have exactly the same issue there, by the way, in the comments that we nicely patch away, which, by the way, maybe we shouldn't patch it all away, maybe we should just comment it out. But so as they have here exactly the same issue here, I would say, you know what, either it is that or it is similar. And by the way, welcome to this channel. We love not only low-level stuff, but also hand editing patches. So the question now is only, do we try that first? And maybe we do, because that is more popular and common than Musel. So that would be PowerPC T2 Linux GNU and PowerPC 64 T2 Linux GNU, and then PowerPC 64 Linux Musel. And last but not least, probably never used, but in case of there you have T2 PowerPC 64 T2 Linux Musel 2. Then what do we need to rebuild? Let's maybe wipe. So yeah, this should be the cross-compiler, which is our ADM logs as previously mentioned. One clang and oops, that is also the wrong build. PowerPC. Also, where is my here? PowerPC, nice. And 20 PowerPC 64 32-bit default there. Hey, and in the meantime, PowerPC Firefox build for AMD 64, of course, in just 15 minutes and 10 seconds. Welcome to epic thread ripping Ryzen 1550X territory. But yeah, if you try this at home, this is performance boost optimized curves, Derbauer offset plate, liquid cooling, and so on, you name it. GSD plugins base for the GStreamer. Actually, why do we have maybe plugins? Yeah, maybe Firefox only needs a GStreamer there. Otherwise, I would wonder why we built this after Firefox. Again, GSTV, probably GStreamer, either only have for Firefox and or WebKit GTK. But of course, you need some base plugins for some base stuff to work. libgphoto, just shipping some good old-fashioned camera, or otherwise P2P or whatever, the picture-to-picture transfer or whatever. PT, picture-to-picture protocol of, is it picture-to-picture? Not to quote here. Protocol of, what even does it stand for? PTP for, come on, can you? Fact checking that here. No, it's not precision time protocol. That should be some picture-to-picture transfer protocol or whatever that was. Picture transfer protocol, picture-to-picture. This is why I was fact-checking that, because it sounded strangely. Yeah, so PTP, picture transfer protocol, of course, developed by the International Image Industry Association to transfer pictures from cameras. We are coming to an end, so yeah, probably 2 minutes 30. Didn't make that up, maybe even short of with all the latest smart optimization, building in TempFS, all the optimizations. Liquid cooled Derbauer offset plates, and last but not least, of course, the most optimized one of the most optimized Linux distributions here, built live on this channel. T2, of course, probably even managing to build Linux from scratch, fully automated and highly optimized. Here, live on this channel in less than 2 hours 30, probably because after VI improved, we only have the Linux kernel left, I guess, and that should usually build in less than 5 minutes, probably on an NVMe PCIe 4, PCI Gen 4, otherwise building in 10fps. So also, by the way, after 3 years live here on this channel, may I present to you finally the verdict without any, who of those recurring subscribers and members remembers how many random build errors we had 2 or 3 years ago with increasing complexity. But yeah, nothing like 3 years live here on YouTube and build this through without a single or random build error. And yeah, libg photo for that photo access stuff, just to ship some, not that everyone, but probably even some smartphones still use this protocol if you want to get some photos out of there. And otherwise, yeah, VI improved. And what else did we have in the meantime? Yeah, some more file system utilities of, what else did we have there? Actually, quite some stuff scrolled by while we had this in scrollback. Yeah, X2 file system stuff, eject, so that you can eject for an optical media on mostly Apple eject buttonless Apple systems, like even an installer, for example, in case you're wondering why we build such strange stuff by default. BetterFS programs, DOSFS tools, creating your bootable FAT partition, RiserFS procs, although probably nobody's using that really anymore. I'm not sure what. DTC device tree compiler, just added that some days ago for not PowerPC, but Apple ARM M1 N1 Mini, booting Linux on Apple M1 and Pro and Max Silicon here, already tested live on this channel and live streaming from that obviously. And added DTC just for Mini. Also, yeah, because if we add something to the default minimal desktop stuff, then we add this to all architectures. Although we mostly need this for ARM, certainly nice to have for PowerPC, but otherwise test building this for if you boot x86 on your OLPC with device tree and open firmware, obviously, right? OLPC X1 or whatever that name was. So RiserFS procs, LVM2 for logical volume management, which of course we usually do by default on servers and stuff. Where is our scrollback? Hello. Otherwise, what scrolled by in the meantime? LVM2, then of course smart mount tools for you. Smart defect monitoring, crypt setup for obviously full disk encrypted setup these days. Proc info, proc PS for the usual process and proc tools. Cron for scheduling time cron jobs. NTP for having also, yeah, crazy large, not a fan of that, crazy large implementation for just client-side NTP. I'm usually not. I think I need to find another. Of course, we have replacements like Crony, but shipping the standard default thing, probably a little bit complex for that task. But otherwise, RPC bind, probably for NFS as this RPC SVC protocol stuff for modern NFS implementations. Then, of course, eventually NFS utils, IP tables for some basic firewalling, IP row 2 for this modern aka 15 or so plus years. Linux default IP routing stuff, key utils, that was used for whatever. Then, of course, open SSH for that, secure shell, remote login stuff, Clang. So let's see, we built also, maybe we fixed the other Winwin, not only found the typo reading some package metadata live here on this channel, but also, yeah, fixed the typo, shortened that to 80 characters, how it is supposed to be in T2 packages, and maybe even fixed Firefox for PowerPC 64 with 32-bit default user space as we optimize. I have a PS3, but I don't want to break it holding it to the camera. You have seen this before. So yeah, if you want to support all the stuff like PS3, Linux, or Linux and anything else between your ARM phone, your ARM 64-bit Apple Silicon, latest and greatest, RISC-V, and maintaining everything and that in between, don't forget to share links, to subscribe. tell your family on Christmas, New Year Eves. Otherwise, if you want to support, if you want to play around with this in this pandemic lockdown times, here is one amazing Tetris-like Sudoku puzzle for you playing along at home. ipconfig for small initRD. Yeah, not the most amazing code quality and stuff, but otherwise super small, minimal ipconfig stuff for initRD, like otherwise a busy box, but otherwise ipconfig. libnl for, should this not maybe built before IP tables or so? Some stuff to fine tune. ITF8 proc probably needed for something, for UTF-8 Unicode processing stuff. Looks a little bit suspicious that we built this at the end. I have the feeling that could be built a little bit earlier, but otherwise. DHCP similar to NTP, a little bit crazy. Yeah, this is also by the way the recurring criticism. NTP, DHCP, legacy decade-old code bases that are really too humongous, totally monstrous code bases that they should not be, and prime examples that we probably should not ship by default because they are too much humongously probably buffer over underrun, this kind of stuff that you find log4j, like recurring C, although log4j obviously Java, but otherwise C, memory, safety issues, and otherwise you probably don't want to run a DHCP server and NTP server with this code bases. And it is crazy and certainly not amazing that we ship that. I should probably change that to more lightweight alternatives because, yeah, building 1 minute 20, this humongous, even I think DHCP including bind, totally not amazing stuff. Yet we have of course that reference implementation just said. It is crazy that these reference implementations are so large and so C that I would actually not even recommend those for anything. So actually, by the way, pro tip, update UT2 not T2, update UT2 of course at home, but update your to-do for not shipping NTP and DHCP. Hello, smaller alternatives instead. Eventually coming to you in 2021. You probably want to share, like, and subscribe for that, or vote below, leave a comment below. What do you think about those reference implementations? Do you recommend them? What do you use instead? As promised, not much to build here. That is one of the last stuff, but unfortunately, due to all those time-wasting micro dependencies and grub2, EFI boot manager, EFI val library, and subversion to be able, of course, only shipping that so that you are, so certainly not many people using that. Previously praised CVS successor, nowadays, of course, replaced with Git. Only building that not only to test our APR Apache portable runtime cross-compilation setup, but so that you on your fresh T2 install at home are able to check out the T2 sources and play along and build sources fully automated at home, parted for that alternative, partition manager, NTFS procs. Not really needed, just to ship that for rescue purposes or work with your NTFS Windows multi-bootloader stuff or so. Just some libiso fs ISO 9660 CD file system to be able to create and burn ISO images by default. So yeah, this GDB, the GNU debugger building here as one of the bigger packages at last. A little bit more unexpected big packages at the end than I expected. I was saying we are coming to an end with Linux, so we actually probably still get a full 2 hours 30 here for fully automated building a Linux from scratch, cross-compiled to any supported architecture. So GDB with that. Also, this still doesn't build, so that tiny fix did not fix that, unfortunately. Back to the drawing board for Firefox there, but is it still the same or is it some other build failed with, yeah, still not finding C standard int, but it probably should be something of that sort, so I will debug that, finish debugging that. Now the dash new default shell there, Mesa demos just to have GLX gears and glx info. Actually, more glx info. glx gear is not the most interesting, but probably you want glx info for your glx information query at home. What else did we have there? Mesa demos dash tmax, only shipping this as added bonus so that you have this terminal multiplexer for your fresh T2 install. And now really coming to an end, of course, Linux firmware is a big package, only copying files 10 seconds and compressing that. This is actually rather large, thousands of files, probably compressing. I think in the meantime, with all the AMD and NVIDIA firmware and Intel wireless and so gazillions of humongous of firmware files of binary nature, rather large. I think maybe even hundreds of megabytes compressed down to also something pretty large. And now the Linux kernel. So the Linux kernel is nearly the last package. After that, we only have some sys files or whatnot. So yeah, 2 hours 30, as I always said, at least if you build this with 32 mostly embarrassingly parallel threads on epic thread ripping Ryzen 5950X or faster performance here live on this channel. I hope you enjoyed this fully automated build of Linux from scratch here, and including Firefox, Mesa, even Wayland support Glue and Xorg, certainly Mesa, and even Vulkan, Lotus, and video isolate support libraries, and all the other 300 support libraries in between. You can actually check that. Create error list for config x86-64. That, of course, only leaves us with 2 packages to build. So probably just some finalizing. We will see whatever package the last one will be. I hope you enjoyed this quick, mostly fully automated video with some PowerPC Clang debugging, Rust, cbind, gen, and Clang debugging. We actually could check what this does now for. Actually, we can also use a new build here that we just. That would be still test C of include C standard int or so. What was it? C standard int? I hope it was. Actually, we can C standard int in error. Hello, error. Also error here, and C standard int. I think that is what I have in the C standard int. So Clang. Of course, this will probably look the same. C standard int. Oops. C standard int. And it is still looking in some PowerPC wrappers, so something still didn't much improve. They actually, the question would be, it's mostly looking in, actually maybe it is, we should probably check if it is PowerPC 6042 Linux GNU. Of course it does. So okay, it does that. And it even succeeds in doing so. User lib64. Okay, here's CRT begin and open at GCC PowerPC 60. Oh, so here's a typo, I think. So it's trying their stuff, and I have a typo in there. Good that we also attention for detail. Of course, it's always best to type without typo, but there's also Clang. What was the path? Something of usual typo of here. Wait a second, we didn't even build that. User, so there was a typo. This was not what we edited. Then I but this is what we have. Then I wonder if we configure clang correctly, because that is not the defaulting to PowerPC case. Anyway, the issue is somewhere there. Are also Linux finished in just 5 minutes and 9 seconds. I think this is not as fast as it could be. Also, the last packages was manpages, which we, by the way, built last, probably to avoid shared files with already installed manpages. So that concludes a full Linux build in full Linux from scratch, completely bootstrapping with all the cross-compile toolchain out of nothing. Headers, C library, Linux headers, C library headers, cross-compiler, then Canadian cross-compiler, building multiple packages twice, once for the host, then for the compiled target system, and some packages even 3 times. For example, GCC for a initial not full-featured compiler, then the full-featured, more full-featured cross-compiler, and then the target Canadian cross-build host native compiler. And I hope you enjoyed this and are either impressed by the targets supported in T2 and also did there some arrow up and stuff. That is what you get from 2 hours. I hope I didn't mangle the config, but we will fully auto-regenerate it anyway. So yeah, that's it for this video. I hope you learned something and got some understanding of how Linux systems are built from scratch, how T2 does it, and how T2 helps with having all the metadata, patches, and configuration to fully automatically do so in 2 hours 30. Don't forget to share and subscribe, sponsor the stuff at GitHub, Patreon, YouTube membership, GitHub sponsors, or OnlyFans, or simply share, like, and subscribe. And I hope to see you soon for more in-depths and hopefully fixed PowerPC 64 defaulting to 32-bit user space, building Firefox to come.